Good afternoon, and thanks so much for joining us at lunchtime today. Hopefully for some pizza if you asked for one, and certainly for some great information today. This is Chris Riley with System Source. I'm joined by Alex Wilson, who's a senior wireless consultant, and we're going to be diving into at least 10 lessons that we've learned, but we'll say it's 10, but it's probably going to be a whole bunch more. But at least 10 lessons that we've learned from designing and implementing, supporting 500 plus Wi-Fi networks over the years. So I think this will be a good session because most folks really have a kind of a narrow set of experiences with kind of designing and implementing or supporting Wi-Fi networks. Typically the one that they're working on now and maybe one before, because most folks are not implementing these very often. They tend to stay in place for a long period of time, maybe with a little bit of care and feeding. So hopefully this will give you some good ammunition for either improving the one that you've got or securing the one that you've got, or if you're looking at doing a large change or adding additional space, those kinds of things, where you really need to look at what you have in place for Wi-Fi. This will give you a lot of good information. So the benefit that Alex brings, of course, to the table is he's seen literally hundreds of wireless networks. Versus just one or two, which most of us may have seen because that's where our experience is. So hopefully this is going to give you a lot of information, whether it's for your existing one or an expansion one, or perhaps even for your next one. So with that, looking at the agenda, so we'll be looking at those kind of top 10 lessons, as well as looking at ones that are related to money or design or vendors, as well as other lessons. And if there is time at the end, because we've got a lot to go through, but if there is time at the end, we'll talk about state of Wi-Fi today. And regardless, you will get this deck as well as the recording of this session made available to you, so you don't have to write furiously. And then at the end, there will be Q&A, and we'll talk more about that in just a moment. So hopefully you've got your pizza if you've asked for one. If not, just note Julie Dellinger's email address on the screen. If it hasn't shown up in the next few minutes, you can go ahead and reach out to Julie. All right, during the webinar, so first is the audio is in presentation mode, so you can hear us, but we won't be able to hear you. But we do that so that any background noise, music on hold, those types of things, where our participants may be, does not come through to the whole session. So you can reach me at any point through the chat. I'll be monitoring that throughout the session. And any questions that you have, we know to talk about a Q&A. We'll be doing that at the end. Just put any questions that you have right into the questions tab. We'll save them up, and then I'll read those out to Alex at the end, and he can go ahead and respond to those. And I mentioned that the presentation and recording will be sent out to you later on today. There is an evaluation at the end as well. We'll try to make it a little bit fun for completing that by doing a drawing for a $50 Amazon gift card. But it's important to us to let us know how we did so we can do better, because we take these educational sessions seriously, as well as what resources that you might need after this based on some questions. And I'll mention a few of the things that are listed in the evaluation towards the end, but you can also just let us know, here's what I need, and we'll try to make sure that we get that for you. Okay, just a little bit about System Source today. We have lots of old System Source friends with us, as well as some new. I just want to welcome the new folks. So we've been around since 1981 at System Source, and we work with IT professionals in Pennsylvania, all throughout Maryland, down into the DC area. So one of the areas that folks will first come to us is when they need to acquire new technology, either on end user computing side, laptops, desktops, printers, those types of things. Or most of the work that we're doing is going to be in the data center, probably 80–90% of the work that we do. So whether that's as well as just IT infrastructure related work like wireless. So whether that's going to be the traditional data center on-prem, or it's many cloud variants. So most of the work that we're doing in the cloud is going to be happening in Microsoft Azure, and then comes Amazon Web Services. But also, regardless of where you put your data center resources, whether it's for your compute and storage and security, whether you're putting it on-prem, in Azure, in co-location facilities, at our locations, you have also on-prem pieces. So what we're seeing is most of our clients have a variety of resources and oftentimes in all of these places. So we help design, implement, support, and secure data center solutions across all of these locations for computing technologies. And one of the areas that we're doing, of course, is Wi-Fi and the security of Wi-Fi, and other network infrastructure things like switch replacements and firewalls and those types of things for on-prem. All of these things for being acquired because they want to improve. We talked a little bit about consulting and cloud. Also available is training on all of these things through our learning center. And there's about 600 to 700 plus courses available at any one time in our learning center on all these technologies that I just mentioned, plus about 2 or 3 dozen more. Where it says present is our professional AV, so all the Teams rooms, WebEx rooms, Zoom rooms, so all the large monitors and projectors and microphones and speaker systems and digital signage, all the way from working with architects and designers while they're doing all the design work, all the way through installation and support of those things. And then finally, we maintain the things I just talked about, either on you call us when things go bump in the day or the night, under service and support, a reactionary model. You call us when you need help, and including after hours. So if you need help after hours, whether you have a contract or not with us, you can just follow the voice prompts and our main number after hours to get to the on-call staff, or managed services where it is proactive, where the IT department for dozens of organizations. So that's a little bit about System Source today. We have one upcoming webinar later this month on the Verizon IT the security report. So many of you may be familiar with that report. It comes out each year looking at actual incidents that's occurred and lessons learned and drawn from that. We'll be going through that in depth on the 25th. And then soon, watch your email box. You'll see events showing up for next month. With that, let me hand the reins over to Alex, please.
Alrighty. Well, good afternoon, everyone. I'd like to welcome you to Top 10 Lessons Learned. This is basically, 12 years and hundreds of Wi-Fi projects. Just some of the various things that we have encountered over the years that you may be dealing with and maybe don't even realize it, or things that you're liable to encounter as you're moving forward. So a little bit about me. I've been in the tech world since about the time the internet concept was invented. So I'm not talking about when Al Gore invented the internet, but as the old joke goes, but a lot earlier than that. I am a networking and wireless consultant. I've done a lot of work in the Wi-Fi space, as well as the long-haul microwave, point-to-point, point-to-multipoint, help build out a lot of ISPs. I also do tower building, climbing, and fiber leasing work. So been around the wireless industry quite a bit, as well as networking in general. So let's take a look at some of the different things that are going on here. And so first ones I want to talk about, let's talk about the ones related to the money side of things. So, the first lesson that everybody learns in a wireless project is oftentimes that was a lot more than we had expected. And that doesn't mean you didn't plan properly. It doesn't mean you weren't prepared for this, but sometimes there's more to it than just changing out your access points. For example, maybe you didn't do a proper design. You're just going to do a one-to-one, and you're going to take out the old and put in the new. And then you find out maybe the coverage isn't quite the same. Maybe you're exposing flaws that were in the old design that way. And so you tend to need more EPs than when you first did it. In addition, sometimes you need new switches because a lot of these newer access points require higher PoE budgets. So as a good example, most of your Wi-Fi 7 APs are going to require either 8023 AT, which is also known as PoE Plus, or 8023 BT, which is known as PoE Plus Plus, versus what we have today, which is just straight up 8023 AF for the most part. So they put a much higher draw. Some of these are going up into the 20 to 30 watt draw range. And so with that in mind, you're liable to need bigger switches. Converse to that, when you need bigger switches, your closets and everything else are going to heat up more. And so that also raises the need for more HVAC because you're drawing more power, you need a bigger UPS. And so all of these things add up. And then one of the other big ones is the wiring. And so a lot of buildings that I've been through a couple recently that were all Cat 5e, which is fine for older Wi-Fi technology. But if you want to fully leverage the newer technology, many of these access points are coming with multiple Ethernet ports, so they can bond two 5 gig ports together, for example, or they can bond two 10 gig ports. And as a result, we need, or we would want to have support for 2.5, 5, and or 10 gig per second connections. And with that in mind, you might have to upgrade your wiring to Cat 6, Cat 6A, add in fiber between your switches instead of older copper, and things along those lines. So you're going to really need to do some beefing up in that realm. I do not recommend pitching a cost to management before you have done your design. I have run into this one a number of times where management's really pushing the issue and they're making demands of you that you give them a price tag before they'll authorize you to even have a conversation with the vendor. Be very, very careful of that situation. I like to say, obviously don't put the cart before the horse. Oftentimes, this goes back to that first slide, which is there are going to be things that you didn't expect. And so if you're just looking at it, and a great example was a client that we worked with many years ago where the IT team was pushed and all of their sites were roughly 50 to 100 APs at that point. These were very large factory sites and they were older technology. And they told management that at best it was going to go up about 25 to 50%. That was it. Unfortunately, it doubled to tripled based on what technology they wanted and the demands they were putting on it. And so, needless to say, management was surprised, which, you're going to be very careful with this. There are many people out there that'll use formulas to try to determine how many APs you need, like 1 AP per 1,000 square feet. There's no basis for this. I mean, if it's all wide open space, yeah, you could sort of come up with a formula that works. But when you're talking about offices, warehouses, schools, hotels, hospitals, lots of walls, lots of different construction, trying to put a number is just going to give you a very basic idea of where you stand. Another one I often hear used, and I will use this one in a residential design, as a recommendation, 1 AP per 2 walls to be passed. So that's okay in a residential environment, but not really in an office environment. And so the challenge you have here is if you set the wrong expectation, it's going to be difficult to change them and move forward with the correct design. Management has a tendency to want to shoehorn you into one particular number that you gave. Number 3 lesson, cut corners, prepare to bleed. Oftentimes these savings look great on paper, but do they really pan out? How much does downtime cost? So one of the shortcuts I often see is skipping a design and going with a 1-to-1. And so if you do that, and you've already got problems as it is, and you end up having problems now, think of how the morale of everybody is. They were expecting all this to improve their life, and now it's just the same as it was yesterday. And so that creates a bit of a depression amongst employees, or frustration. How much is this downtime really going to cost you? Because now you got to go back and redesign it. Now you got to interrupt everybody again to go put up new APs and maybe run wiring and so forth. So there's a lot of issues you can run into. Another big one is using low-cost wiring. CCA is a common one we find. Now, most reputable electricians and data cablers will not use copper-clad aluminum wire. They'll only use solid core copper. However, oftentimes people don't realize what they're using because somebody in purchasing ordered it for them, and their mandate was to get it cheaper. And so they went with a lower cost product. Well, the issue with CCA is it won't carry your PoE all the time. It'll work sometimes, but not on your long distance runs. Then also there's the, picking low cost vendors who lack really good experience. And so, we've compiled a collection of some of these things that we've discovered over the years, like the one in the upper left where they zip tied an AP over an existing one rather than take the old one down, or, pulling a wire out of the wall and plugging it into the outlet. This crimp just makes me cringe on the upper right-hand corner. Now, you could get away with that with Cat 5, but if you try that with Cat 6, it's probably going to fail. Same thing with the ones on the bottom. It's just too much wire untwisted. The other day, I was in a bunch of patch panels that were all Cat 6, and they were all untwisted in this manner. None of them are going to pass for or certify to Cat 6. They'll pass at Cat 5 performance levels, but they're not going to pass for Cat 6. And of course, just multitude of other, funny things that we find throughout the years, and shortcuts that were made, like bungee cording an access point to the wall on the lower left corner, or taping it to the wall. And I've actually encountered that in very high-end installations. Putting a cage over an AP is fine in a gym as long as it's a plastic cage, like the one in the top center. However, that was a solid metal cage, and so you're not going to get very far with that. So what are some of the lessons we've learned related to the design? Well, one of the big ones is that good signal does not always mean good service. And so when you're walking around with your phone, looking at your phone going, well, I've got 4 bars here. Why are they complaining? Well, you can have good signal, but if there's noise or interference in that area, or near the AP, or near the client, or along the path of the communication, that's going to cause issues such as latency, packets being lost, things along those lines. And when you have that, your good signal suddenly really doesn't matter, because the quality of the connection is not that great. And so the standard test is just walk around with the phone and see if you've got 4 bars or 5 bars or whatever, the max bars you can get on your phone. And that's not a valid test. That is just one element of all of what's going on. And so I'm not saying it's a useless tool. I'm just saying it's got to be used with the right context. It's just one piece of it. Yes, I've got good signal, or no, I don't have good signal. And if you don't have good signal, then that's probably where your issue lies. But if your signal's good and they're still complaining, we need to dive deeper. And also, too, 2 identical devices can actually read differently. And so if you walk through with your phone versus their phone, you could get a different reading. And this is because of manufacturing issues. They're not manufactured to very tight tolerances. So here's a really great example of this in a chemical mixing plant. This is a warehouse with production areas, so a lot of liquids in totes, up on high racks. They went up as high as about 40 feet. The users were complaining of dropped connections, delays, lagging, garbled calls. They walked in with a phone, the client themselves, they found good signal. They didn't understand why it didn't work. They had a vendor come in. They did the same thing. They concurred signal was good, except for in a couple of areas. They couldn't figure it out. Second vendor, same problem, except the second vendor just said, just buy, some junk Wi-Fi system. And I don't remember what the brand was, but it wasn't really a high end. It was more consumer grade. And there was no evidence to support that this would fix it. So we came in, we used our higher end tools, and this is what we found. So this is an actual heat map of this plant. There were a couple of areas that you can see in gray where there was no signal. Those were expected because of the way the warehouse was laid out. Those didn't really concern me that much, because we can fix that by adding appropriate access points. But if you look at the other areas that are circled, you'll see good signal strength because you're seeing mostly green, a little bit of yellow, but mostly green. So that's, considered good signal. But yet they were complaining of problems in these areas and others as well. But as we started to dive in, this is the noise. So we were able to filter out, not just look at the signal strength, but now let's look at the noise. And so these areas that are circled all had high levels of noise. And so now the question is, what's causing the noise? Now, normally noise would be caused by APs being on the same channels, potentially, which we do have a little bit of that here. They weren't really managing their channels very well, but outside of the channel management, the real noise issue, it was deeper than that based on what we were seeing. And so the next thing we pulled up were the interferers. This was a problem. We should not be seeing pink everywhere. This indicates that there's interference in every location. Now, interference means it's seeing something on those channels broadcasting in Wi-Fi. Noise could be something generating noise on the same frequency, but it's not Wi-Fi traffic. So it could be, for example, noise could be caused by a radar beam that's on the same frequency, for example. But interferers are direct Wi-Fi issues. And so we were trying to figure out what was causing this. And we had to do some deep digging. And then, so the next step we started looking at too was channel utilization. And what we were seeing was a high number of usage on each of these Wi-Fi channels, each of these 5 gig channels. Anything you see in pink or deep orange is almost 100% usage. And so that was a concern because they had very little traffic in here. Through a little bit of sleuthing, we basically figured out, all right, signal's good, a couple of areas of concern, no big deal. They were using the wrong APs in a warehouse. So they were using omni antennas, which are, creating a pattern that goes all around. They should be high gain, directional. Noise was very high in some key areas. We found a lot of channel overlap. We eliminated that through reconfiguring, but that still didn't help. But these interferers, we did some digging and found out that the sensors in their LED lighting system were not based on IR, they were based on 5 gigahertz. So they were actually using channels 149 through 161 to check to see if there was somebody moving in an aisle. So they were using it like a radar. And so we had to go through the manufacturer to find out what we could do with this and try to get it moved. So basically, we got the lighting vendor to contain the sensors to one channel, and we avoided that channel on all the APs and then gave them a proper design, and that solved a lot of the problems. Now, another big issue that we see with this is these one-to-one upgrades. So this is another big lesson. Will they work? Sometimes. Will they work all the time? No. And so if you had a bad design before, you're still going to have a bad design moving forward. These newer APs are not broadcasting further necessarily, especially on the upper frequency. So if you had an old 2.4 network, you covered everything from one end of the building to the other with very little effort. And then when you moved to 5 gig, it reduced the coverage pattern. And then when you go to 6, it reduces it as well. It's really no different than what the cellular industry went through when they went from 3G to 4G and then on to 5G. And so this example really shows the coverage areas. So if you look at what the 2.4 AP is covering versus the 5 versus the 6, you can see the difference in the coverage patterns. These are all scaled the same. These are running at the same power levels. And so cutting back could become problematic. Now, this isn't always going to be the case. Sometimes the materials in the walls will attenuate differently on different frequencies. So you might have some walls that react a little bit different, but by and large, this is what reality is. You're going to see about a 30% reduction in coverage on 5 gig and about a 50% reduction moving to 6 gig. Another one we talk about that we run into, especially in schools and hospitals, hall-fi is what we refer to it as. It's where you put all the APs in the hallway. It rarely works. It's typically done because it's easy installation. The hallways are just a straight wiring shot. Many times they're drop ceilings, whereas the rooms might be hard ceilinged. What you end up though with is too many APs seeing each other, and then you typically overload the APs with too many users. And it's hard to get them into a good position to serve all of the space you need to serve. So here's an example where hall-fi was set up. This is a standard school with 4-pod classrooms where you've got 4 doors all centered around the access points. And you can see coverage in the periphery is not the greatest. And in order to even get it to that point, we really had to crank up the power on these APs. Well, the problem that you run into when you turn up the power is that you're now overlapping the other APs by way too much in the hallway. And so this is what you actually see. This is isolated to just one access point. And you can see how that access point covers up and down the entire hallway. So do the other 3. And the problem you're going to run into that with that too is you're going to have overlap into the rooms as well in some cases. And that overlap into the rooms might become problematic in that you may hang on to an AP that's not the best connection, but you're not hitting the threshold to flip over to one that's closer. And so we get what we call a sticky client situation going on. And so we want to try to avoid that. And the way to do that is really to put them into the rooms, whether it's a 1-to-1 or 1 to every other room, really depends on your population, number of users, the type of work they're doing, and ultimately the construction. Surprisingly, cubicle walls can be quite devastating to RF. Typically, most cubicles are made of metal, and then they have some fabric covering over top of that. The question is underneath of them, are they solid metal or are they, open metal with, holes throughout it? Kind of like if you think about a standard studded out wall, is there pass-through space between them? Knowing how they're constructed is really going to help you understand it better. On top of that, things like the cabinets hanging over top of the laptop. So if the laptop sits on the desk and there's a cabinet above it, that laptop may be getting blocked by that cabinet, which might have 2 or 3 layers of metal that it's adding to it. Plus the contents in the cabinet, which are going to vary from desk to desk. Obviously, the taller the cubicle wall, the worse it gets. We've actually been in some offices where the cubicles are 7 to 7.5 feet tall. So they're more or less full walls. And it creates quite the mess for RF. So this is a great example where we have the cabinet across the top and shelving, and the cabinet door, is open. So it's blocking what's coming underneath of it, or what's getting underneath of it, which also would affect your phone while you're sitting in your chair. Another interesting lesson, and this is kind of about materials in general, but interestingly, bullet-resistant glass may stop a bullet, but it doesn't really do much to RF. And that was kind of a surprise that we received when we were testing it not too long ago. But we've run into issues with glass, like your typical outdoor exterior windows with UV coatings can result in a 10 to 20 dB loss of signal, which is pretty much everything you need to survive. Bullet-resistant glass was more like 2 dB, which is actually less than most drywall. Now, plate glass can be 4 to 7 dB of loss. It really depends on how it's made. Also, keep in mind some plate glass interior walls have UV coatings on them as well, so that sun coming through the windows into the office space, like in a conference room that's all glass, it won't carry that sun or the devastating UV rays beyond that. So make sure you're testing these materials and know them so that you understand how the RF is going to be affected. Along with that, a pallet of cardboard can be almost as bad as liquid or metal. It is a very dense material. It's highly RF blocking. This is why when you're dealing with a warehouse, what's in the pallets or what's on the racks matters in your design. And this applies to anything really. I mean, you need to know what's in the walls, things like, your flat screens, your whiteboards, heavy draping, artwork, changing out traditional drywall for impact resistant drywall, which is often used to create soundproofing. We have found that impact resistant drywall tends to be about a dB higher in loss than a standard drywall. But then in rooms where they need to get soundproofing, they oftentimes put double layer up. And so you have to factor that into the design, as well as all your HVAC and wiring and plumbing, bathroom stalls. Even if you're not trying to cover the bathroom, if you're putting an AP on one side of the bathroom, hoping it's going to reach to something on the other side of that bathroom, you better be factoring the stalls that are in between into that design. And so this is a great example of an access point in an aisle in a warehouse. And this is actual live testing. So we put the AP right in the center of the aisle. These are about 220-foot aisles. This is isolated to the AP in the middle at the moment. And you can see nothing escaped through the racking into the other aisles. And these were not even completely full racks. Most of these racks were, I would say, about a third to half full, and yet nothing emanated outside of that aisle. So basically, each aisle became its own isolated environment, which makes designing it a little bit easier, or at least I should say configuring it, managing the channels is easier. So some lessons related to your vendors. Number 10, this is, I'm not going to say it's the end because right off the bat, vendors stretch the truth. So I'm going to stretch it a bit too. We're actually going to go for 15 lessons, not 10. But, they talk about things like the range, the capacity, the performance. I'm not saying they misrepresent the numbers intentionally. The industry has just tried to find ways to represent their numbers in ways that people can understand and grasp easily. And so oftentimes when you'll see, this access point will support, 5 gigs of throughput. That's not 5 gig on one band. They just take all the band's maximum and put it together. But that's not how they work. You're only working on one band at a time. And so the number can be a little bit misleading. Oftentimes too, they'll give a range that, this AP will support up to 2,000 square feet. Ignore all of that because that's 2,000 square feet of open space with no obstruction, no interference, no users. That changes everything. So these numbers are based on perfect situations, which really do not exist in the real world. A lot of vendors out there will buy fancy tools, but they never really learn how to use them either. They'll purport that they do wireless design. They've got, Ekahau and a Sidekick, and they can come in and do their design for you, but they really don't understand how to leverage it. They haven't invested the time and the training into understanding wireless. And these tools are not cheap, and they have very high learning curves. I mean, a typical Ekahau plus Sidekick will set you back $8,000 to $10,000. Throw another $6,000 for 2 weeks of training, and that's just getting you started. Now you got to take time to learn and really understand the nuances of wireless. An old word of wisdom that I always used to use in my EMT classes when I was teaching EMS classes: treat the patient, not the monitor. And so people who don't understand wireless will focus on what the device tells them, what the testing equipment tells them. They're not going to focus on what the users are actually saying or understanding that while the monitor says you've got good signal, does that really mean you've got good wireless? And so if they don't understand how to dig in and understand all the different pieces, then all these tools are really useless at the end of the day. So some other important lessons. One I often hear, and this isn't exactly how they word it, but it usually comes out as, Well, I've got Wi-Fi at home and it just works. So why isn't this stuff working that I paid way more money for? Well, there's a big difference. Consumer grade equipment, the focus is on coverage, not on capacity. It's designed for a residential situation, which has, 3 or 4, maybe 5, 6 people in the household, 2 or 3 devices each on average, plus some IoT devices. It's not dealing with the type of stuff you're dealing with in an office environment. These are also typically very ugly APs with lots of antennas sticking out of them. Not always, but that's a common thing. Those aren't things you want in an office. Besides, if you let the antennas hang down from the ceiling, they will get rearranged, either by people walking through the office just reaching up and slapping them, or by equipment going through, or in a warehouse environment, by the forklifts. So you want to make sure that you're using commercial grade stuff in your designs and in your installation, and understand that consumer grade is more concerned about sheer throughput, which is something that the average person can grasp, and it will sacrifice reliability as a result. Plus, they tend to lack the security and control needed in a commercial environment. I also like to say bigger is not always better in these environments. So you want to focus on reliability and stability over speed, whereas many vendors want to emphasize throughput over stability or reliability by using wide channels, high power, what I like to call the secret sauce voodoo, or different functions that they add in their device to try to defeat some of the rules of wireless. They also like to use big antennas, whereas narrow channels and properly sized coverage cells via power management will win out almost every time. The wider your channels, the more susceptible you are to noise and interference. And so our standards have always been, and this is an industry-wide standard that doesn't get followed by any of the vendors, but it is followed by those who actually do the designs and those who write the certifications and the training programs for the wireless industry. But 2.4 runs at 20 megahertz, channels 1, 6, and 11, alternate them, set the power 7 dB less than 5 gig, and you're good to go. 5 gig at best, use a 40 meg channel, take advantage of all the channels, including DFS, get your power up to about 19 dB, and then adjust from there. And then for 6 gig, we're finding that 40 megahertz also, typically auto channel, but you can manually set the channels as long as you don't overlap them. And then the power at about 2 to 3 dB above 5. Now, these are guidelines. These are not carved in stone, and every situation is going to be a little bit different. A lot of people are also questioning, why would we use a small channel on 6 gig when you can get such fantastic throughput at higher channel widths? And the answer is simple. If you're using an Apple device and other vendors are starting to move this way, they're going to favor the wider channel over the narrower channel. And where that could become a problem is they'll actually score a wider channel with a lower signal strength over a higher signal strength narrow channel. And studies have shown over and over again that, back to that stability, that narrow channel is going to be more stable in the long run than that wide channel. And I'll actually show an example of that here in a little bit. Wireless networks do run on your wired network, so make sure yours is solid. Make sure you have good DHCP and DNS resolution. Make sure your STP priorities on your switches are set. Avoid cascading and daisy chaining your switches. Obviously, it has to happen sometimes, but minimize it. Avoid mesh and wireless uplinking with your access points where possible, because that creates other issues as well. I'm not saying don't use it. I'm just saying try to avoid it where possible. Make sure you're using the right cabling with that. Cat 6 are better these days. Don't waste money on Cat 7 or 8. It's not going to make things better. In fact, it makes things worse in many cases. because now you have to buy more expensive tools to maintain it. You should be using fiber for your long runs or between the switches. We often use DACs for the short hops. Those are your short pre-built copper cables and or small fiber patch cords that we would use. Make sure you have proper structured cabling methods in place, good terminations, solid, properly tested. Make sure you're using good quality switches with high throughput. This could be another area where you have a great switch that's putting out the power you need, but if it doesn't have the throughput capability, it can become a detriment. And then also look for other sources of noise on your network, things like multicast traffic, poorly run network lines that are laid near power or AM/FM transmissions. Those are all just things to look for if you're having wired issues as well. And then the final lesson, good design and proper tuning will smoke auto channel and auto power pretty much any day. Now, some of your higher end Cisco, Meraki, Aruba, Ruckus type environments, the auto channel works pretty decent, but I often find that in complex environments, it also doesn't do a great job. It will fail from time to time. And so if you have a good design with the right placement from the start, this will save you a lot of aggravation. But then solid manual tuning will win out over auto channel or auto power on most controllers. So keep in mind that the controller is relying on what the AP sees, not what the client sees. And so if you think about this for a moment, if you're in an office, high-rise office in, say, downtown Baltimore, your APs are in the hallway and your office is out on the periphery. Well, the AP is not seeing your neighbor across the street, but you sitting in your office, your device does, but it's not making it all the way into the hallway. And so you're getting interference from your neighbor across the street, but your APs aren't seeing that. So how are they going to know how to compensate? And this is why I say it's oftentimes better to do manual. With that in mind, less is often more. So you don't always need high throughput. What you want is stability. And so those lower channel widths give you more channels so you can avoid reuse. Learn to use DFS channels properly. I wouldn't recommend using the ones dedicated to weather radar while you're sitting right next to an airport, for example, or those that are for maritime radar, while you're sitting next to the Port of Baltimore. You will probably run into issues with those, but use them correctly and they can work well for you. Use the obstructions in your building to assist in blocking coverage. So for example, if I want to use DFS maritime channels in downtown Baltimore, I'm probably going to put that on APs that are in the center of the building, in the core, surrounded by lots of walls, or down in the basement levels, so that they're not getting seen by those radar units out there. Similar, same thing for the weather channels. Bury those in the basement or in the core of the building. In open space, use directional antennas to create cones of coverage so that they don't see each other through the through the airspace above where there is nobody using it. So for example, in the warehouse, directional antennas focus my coverage down on the floor, not on the upper rack. And then you also gain a bonus with lower width channels. So a lot of people don't realize this on 5 gig, but the gain goes up by 3 dB for each reduction. So if you go from an 80 to a 40, you pick up 3 dB of gain. You go from that 40 down to a 20, you pick up another 3 dB of gain. And gain gives you more distance and better penetration of objects. Now, conversely, as you increase channel width, obviously, you lose 3 dB of gain. So this is an example using a ballroom in a conference center. The background, 35-foot ceilings. It's about 240 by 160 feet. It had 6 Cisco APs with internal Omni antennas, full 1 gig symmetrical fiber that was 1-to-1 at the gateway, so we knew the fiber was good. Complaining of fails with roaming, high retry rates, slow connections, lagging video, garbled calls, the same things you're getting every day from your users. And then from time to time, they would have large numbers of users trying to run charges on their phones for purchases in trade shows, which they weren't getting connected. And so this was, what we call the controller gone loco. And so the controller was on auto channel and auto power. This is the Cisco controller, and I'm not faulting Cisco. This just happens sometimes. When we looked at it initially, the power was on full. So every AP was blasting at full power. We had a lot of channel overlap. They were only using 2 channels, basically, because of the channel overlap. And so the signal strength, which is the green image, showed perfect signal everywhere. That was fantastic signal strength. But yet they were getting 10 meg down and about 50 meg up, which is a clue too that there's a problem because we have an inverse download versus upload. And they were hitting latency in the 500 to 800 millisecond range. When we looked at channel interference, which is the gray map, that was 100%. We had at least 2 interfering channels on every AP. So we're not getting anywhere. So the first thing we did was an interim fix while they were waiting for equipment to come in. So they had a long purchase process and acquisition process, and then the parts they wanted weren't available. And there were other things that were delaying this project as well. So we did some interim fixes to help them get by. So we were able to eliminate the channel overlap with manual channels. We lowered the channel widths to 40 meg on 5 gigahertz, and we leveraged DFS channels so that there are no repeated channels in here. Now you'll notice the signal strength on the left is not that bright green. It's a little bit lower, but that's because we lowered the power mainly to keep these APs from, to try to reduce the coverage area a little bit for each AP to get things to roam. The best part was when we look at the right hand where you see the green, that's channel interference. That's telling us there's none. And so our speed tests were now running 350 to 400 meg each direction. That's up from 10 meg and 50 meg. And our latency was down to 10 to 20 milliseconds, which is very acceptable. However, we still have a problem, and that is each AP covers way too much. This is one AP isolated just to show you it was covering almost the entire room by itself. But it's not enough because that AP couldn't handle the user count, nor could it work when they started putting up dividers and panels and stuff for different trade shows. So this is the wrong AP. These were just omnis up on the ceiling. They were too far away from the clients. And so the final design, which I will say we were more or less at nirvana at that point, was to move to a high capacity AP. We stuck with Cisco in this case. We used external directional antennas, which were very focused and created coverage cells that allowed devices to roam from one cell to the next, just like it's supposed to. And we were able to put all of these APs above the ceiling tiles so that they weren't visible. And we just put a painted panel antenna as the only visible item. And so these were very discreet, very clean. Speed tests were now consistently 450 meg in both directions. The latency was consistent in the 10 to 20, which, while it doesn't sound like it was much better than before, what it did do was it also improved roaming. And so now they were able to roam from point to point and switch APs without issue. So the conclusions at 80 megahertz on 5 gig, they should have in theory been able to hit 960 meg, but all they could ever get was 10 meg. And that's because the MCS rates were being driven down by the channel reuse. Dropping it to 40 meg, we hit a max of about 450. The max at that rate is 458. I'll take it. 450 meg with a max of 458, that's perfectly acceptable. So in the end, we did better with less. So we were able to actually hit 450 meg, but we really couldn't achieve that with 80 meg channels. We were just getting hammered with the channel reuse. All of the latency issues went away. And by using the right tools at the right vendor, you can actually end up with good wireless environments. So to kind of bring this to a close, keep in mind, some of the big things, when you do these projects, you are going to run into unexpecteds. Try to eliminate those by working with a checklist, working with the right vendors. Make sure you understand all of the things that could be affected by changing out a simple access point. So don't forget about your switches, your router capabilities, your HVAC, your UPSs. Put all of those things on the table, and your wiring too. Do not put the cart before the horse, so be careful with setting expectations about what it's going to take until you know for sure what you're dealing with. Watch out about cutting corners. You're liable to have some, get some backfires there when you do that. Remember that good signal doesn't always mean good Wi-Fi. It just means you have good signal, and it's a start, but you still have to check all the other boxes, such as low noise, low interference, making sure you have good wiring in place and all the other pieces that go with it. Don't recommend one-to-one replacement. It will usually bite you in the backside if you're not careful. You're not going to be improving on your existing network unless you're just taking it from an old technology to a new technology. You're just not going to really improve the quality of coverage. Try to avoid Hall-Fi. Don't forget those cubicle walls can be quite devastating. So can things that you don't know about in the walls. Keep in mind that, glass, bullet-resistant glass isn't really your problem, but plate glass and exterior windows can do quite a devastation. And kind of an interesting thing on that, I've actually been in an office where they used sliding glass doors from homes as their office doors, and they couldn't understand why the Wi-Fi didn't get in. Well, that's exterior grade glass, and it was UV rated. They were blocking about 20 dB, and so the entire situation was they had to put the APs in the offices or get different doors. Things like cardboard can be just as bad as metal or liquids if it's stacked and packed tight. Make sure your vendor is telling you the truth, or understand that sometimes they like to stretch it a little bit, especially around the capabilities of the equipment. And a lot of these vendors lack some of the skills in wireless. They're great at wired networking, but they're just not as good at the wireless side. It is a very deep subject with a lot of different nuances and does require some different experiences. And then keep in mind, consumer stuff is for consumers. It's not really meant for commercial environments. Bigger is not always better. In the medical field, we often refer to as lowest effective dose. The same thing applies to wireless. Make sure you're just giving it what it needs. And then ultimately, make sure your wired network is up to speed. Otherwise, you're liable to have issues moving forward. And so with that, I see we're almost out of time. Chris, did we have any questions that needed to be answered?
We do have one here. So one of the questions is, our location when originally built was pre-wired with Cat5 Ethernet cabling. Cat6 didn't yet exist at that point. Will this be a problem? That's the first half. And the second half is, in your opinion, who are currently the best manufacturers of commercial AP?
Okay. So the answer on the wiring, Cat5e cable will work. It is only going to rate to 1 gig. That said, you can sometimes get as high as 2.5 gig out of it. But I can't, as a wiring person, I would not certify a Cat5e to 2.5 gig. It just wouldn't pass in the certification. you're not going to get 5, you're not going to get 10 out of it. So if you can live with, only getting 1 gig, that's fine, because you're going to ultimately get your PoE, which is important, and you're going to get a better performance out of these newer APs, even if you're only on a 1 gig network. As an example, in my own office, I'm only on Cat 5 for the moment, and we don't really see a performance issue. I mean, we're getting, good performance, but we're also a low use office. We don't have hundreds of users here. So keeping that in mind, it's really going to depend on your overall situation. That said, if you can move it to Cat 6, all the better, but it's not going to ultimately be, a detriment. It's going to still function. The answer about the best vendors for commercial grade, I'm going to be honest with that. The names that we've all come to know and love or hate, depending on how you look at it, but your big names, your Cisco, Meraki, Aruba, Mist, Ruckus, these are all some of your high-end. Now, Mist is currently being purchased by Aruba, so we're not really sure where that's going to end up. It'll probably get merged together, much like Cisco and Meraki have over the years. Ruckus is a good brand, but they've been on the chopping block by their owner for a number of years. So again, approach it with caution. Make sure they're a solid, vendor. There are some others out there, kind of what I call the outliers. Fortinet is a good product, Ubiquiti, a number of others that fall into that category. But the names that I tend to avoid would be things like Belkin, Linksys, Vilo, Eero. Now, Eero does have some commercial products for low end. I don't really consider them an enterprise grade because they're not offering solutions that go beyond a traditional office environment. And so when I'm looking at a complex environment that may be like an office mixed in with a bit of warehouse, I want those higher end APs that have choices. So I can pick from a variety of omnis, I can pick from some directionals, so I can make sure I have everything I need to present a comprehensive solution to the client. Any others, Chris?
All right, thank you. Thank you very much. That's great. There was one further question. Is thoughts on Ingenious?
Ingenious, I have dealt with a little bit, mostly, I will be honest, taking it out and replacing it because a lot of Ingenious networks were very old. They had a good product for the outdoor space, but there are better solutions for the outdoor space today. More relevant, more current. I'm not going to say they're a bad brand, but they're not really keeping up with that high variety of choices that you find with your bigger names, so like your Cisco, Meraki, Aruba, Ruckus, yada yada yada. But again, they had a good product for outdoor space. They were big on the meshing between remote locations, but a lot of that can be done today with more modern technology.
All right, thank you for that. So just one word. So you will get an evaluation, as we mentioned earlier. So there's several things that are listed on there that may be useful resources for you, depending upon where you are and what you need. So one is if you just need a Wi-Fi planning workshop, there's no charge for that. If you need kind of a Wi-Fi site survey or design, we talked a lot about design today. Also for kind of a troubleshooting, maybe you're having difficulties on your network and that may be useful to you. And then, or you may need additional training or equipment. So just some things that are there where you can just list how we can be helpful. With that, I want to say thank you very much to each of you, and thank you to Alex as well. Hope you have a great afternoon. Thanks, everyone.